I'll introduce you to Les and Trevor, who are on our panel today. So all the questions have been around Part B that we've had in. Trevor's our training and development principal. He's there, hopefully you can see him on screen and on my shared screen as well. And there's Les Ryder there, head of major projects, our high-rise and fire safety expert. Okay, so we've got some great questions. We'll do our best to get through them. If we don't finish, what we will do is we'll send it round in a document to you. And if there's any questions that you've got that we haven't got time to cover, do let us know. But we're hoping that some of these questions are quite broad and might cover a multitude, so that your questions are answered. Okay, so take it away.
Oh, well, it looks like I was...
You're first up, Les.
I was going to say...
Yeah, so...
It was almost an uncomfortable pause, sorry.
Why are there different classes for flat roofs, walls, such as B roof T4, AA, Class O and A to E ratings? This is you, Les. Okay.
Well, this question, half of this question, that we've got a 1-hour video on the website, which identifies how the A to E ratings manifest themselves. And so it's half of this question's a 1-hour lecture and the other half is 1-hour lecture. So what I'm going to try and do is get through it, in probably 3 to 4 minutes. Otherwise, we're going to be over time. So if you pull the first slide up, Rach, thanks. That's the piece of kit. There's another 2 or 3 pieces of kit, but that's the main piece of kit for ascertaining reaction to fire tests, not fire resistance, for the material. So this is materials, surface materials, i.e. the surfaces of corridors, the surfaces of rooms, the surfaces of external walls. Well, not external walls, but yeah, to a certain extent, external walls too. So it's a material test that ascertains various criteria that, like I said, I don't really have that much time enough time to go into. But that replaced the old national standard, and the biggest confusion between the national standards and the European standards has continued, and they're not easy. They don't marry up very well, but they have given it a good high skill try. And if you ping the next slide up, Rach. That's the national class on the left, which we all relatively familiar with, if we all getting on a bit, class O1, 2, 3, and 4. And on the right, there's all the reactions to fire tests. That piece of kit that I showed you on the first slide, that only deals effectively with A2, B, C, D. It's different pieces of kit, as you can see by those various different European class standards. Just the same as it is with the national class. Now, the two tests that tie up quite well is the non-combustibility test. The national and the European tests tie up really well. And whatever went into the national class as non-combustible came out as non-combustible in the European class. It doesn't make any difference how hard you try and burn concrete and steel. It just doesn't. You just can't do it. So that's the only test that really went across from side to side. Then you see below that we've got A2, which is effectively limited combustibility, and that was tied up with the BS 47611 test. Again, a little bit closer than the next tests that you're going to see. And then, of course, it starts pattern company a little bit. The Class O test and the Class B test couldn't be further apart, but they've classified them together. So if it gives a Class B reaction to fire, then by virtue of that, it gives Class O, and vice versa. all of the national classes have more or less been disbanded, not in the new regulations as far as we're aware. So everything's on A, B, C, D and E, and E and F, of course, is too highly, contributes to fire too high. But basically what we're looking at plasterboard's going to be class B. You know, that's a good indication. Class C, certain timbers will get class C and most timbers will get class D. So that kind of gives you an idea. And an A2 can be some kind of a homogeneous materials where it kind of falls in the middle, but it's still relatively non-combustible. Ideally, they were looking at years ago that limited combustibility was plasterboard, but as you're aware, plasterboard's got a paper cover on it, so it kind of messes up the situation there. So that's a slide that identifies the correlation between the European classes and the national. Like I'm saying, this is quite a complex subject, as you can see. But basically, A1 is non-combustible, A2 limited, B is reduced contribution to fire. That's what you'll see in circulation spaces. That's effectively plasterboard. C is a dense timber. C is a dense timber. D is a less dense timber. You put on the next one there, Rachel. And that kind of identifies what I was saying. But basically, this is not a fire resistance test. This is a material test. So when the fire breaks out, how much will the material contribute to the fire? So that's where it's trying to achieve. Where the fire resistance is how much it can contribute, how much performance separation it gives between certain aspects of construction. Next one, Rach.
That's it for question 1 for slides.
All right. Did you not do the roof? Was there no roof classification slide not on there?
I haven't got the roof. No, that's as far as it goes for this one.
All right. Well, the roof class. I'll explain the roof classifications quickly. That's the the B roof T4, the C roof T4, the D roofs T4. They tie up very well with the AA, ABs, and ACs. And it's basically if you're within 6 meters of the boundary, your roof covering's got to be AA, AB, or AC under the old class, and B roof T4 under the new class. And so basically they tie up relatively well. And again, it's the more combustible the roof covering, the further away it is from the boundary, and that more or less sums it up.
Okay, thank you, Les.
I would say, yeah, I'll just chip in on the back of Les, and he can do the same on my answers. Les said plasterboard class B, and generally it is, but I know you can get class A2 plasterboards, which is handy because otherwise you wouldn't be able to use them on 18 metre plus high-rise residential buildings. So yeah, in case somebody's sitting there thinking, well, how are they doing that? Well, there are plasterboards available.
Yeah, it's just, yeah, you're 100% right, Trev. It's the paper that's replaced, isn't it?
Yeah, I'm not sure how they do it, but they've got it classified and it can be used. But building control need to be sure that it is the right plasterboard that's had the testing and has got the certification.
Sure.
Okay, on to you then, Trevor. Can you explain a notional boundary?
Well, I'll try to. You're going to find some of my answers are a bit Ronnie Corbett-esque in that I'm going to make sure that we go into sort of some base principles and we might deviate around a bit, but I'll be as succinct as I can. Yeah, notional boundaries. This is all to do with spread of fire between buildings, to calculate whether something complies. We have to establish where the actual boundary is, and that's easy. If we've got a housing estate with hedges and fences, that's where the boundaries are. And if there's the road at the front, then we know nothing's going to be built on there, so we can take the boundary to be the centre of the road. So that's fine. We identify where the boundary is. We look at the unprotected area in the elevations, which are doors, windows, areas of wall that don't have the requisite fire resistance, and we tally them up and we make sure that they're not going to emit fire across the boundary, such that you get ignition in a building that's the other side of the boundary. In other words, the next door house. It's all about the Great Fire of London, isn't it? And preventing a conflagration from spreading from one fire. So that's what it's all based on. And then we have these things called notional boundaries. We don't really have to worry about them that often, but where you've got a situation where you've got buildings on the same site, so the actual legal boundary is around both the buildings or multiple buildings, then we have to look at the risk of fire spreading from one to the other. Now, if that's an industrial estate and those buildings are all owned and managed by the same company, we don't worry about it. But if any of those buildings are residential or assembly recreation, which are in building control parlance, purpose groups 1, 2 and 5, then we do have to think about the risk of fire spreading between. And in those terms, we have to look at devising this notional boundary. Can we have the first slide up, Rach? So there it is, all is in the building regulations, and we look at the buildings and we think, right, well, it's reasonably obvious. We'll cite that, but we'll look at the most onerous case, so probably the biggest building or the building with the most unprotected area. We'll work out where, from the tables in the building regulations, ideally using the simplified methods, where we're going to cite that notional boundary, and then we'll check it. Will that work for the other building as well? And if it does, that's fine. That's where we're going to put it, and it complies. Obviously, if the notional boundary won't work for both buildings because of the amount of unprotected areas, we've got a non-compliance issue. So that sounds good and straightforward. It's an easy check for building control to make. But what I would say, and this is covered in another of our presentations that Les and I did, another double act on fire spread between buildings, the building regulation requirements are based on what's called the sort of mirror principle. And what, in setting out these limits of unprotected area, they assume that the buildings opposing each other across a boundary are similar in size or have similar levels of unprotected area. Now, that's fine if it is, but if we're trying to look at where a notional boundary is, we have to have this mirror principle in our minds. Right, slide 2. Because the distance A, which is the distance that's going to be in the tables in the building regs, that actually assumes that the building will be distance twice that away from the building. And that's really working out, as Les taught me, it's 12 kilowatts, 12.5 kilowatts at the face of the building, and then you can get pilot ignition. So we want to avoid that. And distance 2, is that right, Les? Distance 2A will mean that it's safe from that situation. That's great if the buildings are the same size, but if we have the next slide, Rach, what if we've got one building which is a dissimilar size, so it's a much bigger building, or it's got more unprotected area? Well, on paper, distance A complies, there's our notional boundary, and distance B complies, there's our notional boundary. The problem being, we have to think of distance 2B, because that's the point within which the building 1 is at risk of fire spread. And clearly, building 1 in this diagram is within that distance and is at risk, so it doesn't comply. So building control colleagues out there, if anybody's listening, yeah, always have that one in mind as well. It's the same with an actual boundary, notional or not. We have to consider the mirror principle and make sure it works on that count as well. So over answered the question grossly, but hopefully it was an interesting discussion. And next one to you, Les.
Right. Okay. So does a new part B include a section on PV solar panel installations, compartmentation, but roof? No, it generally doesn't, but it kind of revolves around the information's already there. You go on to the next slide, Rach. So this is relatively a quick one. So there's no provision in single houses. So you place your PV panels on the roof, and I would imagine I've seen the inverters and the step-up transformers located in many places, just the same as your consumer unit. The position of your consumer unit isn't controlled. You don't need fire resistance around your consumer unit, and it's probably considered much the same as a risk. The inverters are not generally a large fire risk, and neither the step-up transformers. I've seen them in utility rooms. I've seen them in stairs underneath the cupboards. So I've seen them in a variety of different positions in single dwelling houses. For multiple residences, it's different. So it's not uncommon now for the blocks of flats to be staggered. You don't see like a 5 or a 6 or a 7-story building that goes vertically up and has a flat roof the same size as the ground floor. They're generally staggered, and the staggered part of the flat roof is generally littered with either PV or air source heat pumps. And under those circumstances, all of the switch gear will then disappear through fire resistant constructions with the required fire stopping as those cables pass through the fire resistant constructions of the building and the service shafts. And then of course into an ancillary room. So that ancillary room that gear might go into the low voltage transformer room, the low voltage where the distribution board is, and various other pieces of plant. And that room is controlled. That room must have a minimum of 30 minutes, sometimes 60 minutes fire resistance, just depends upon how you look at it. And there'll be provisions depending upon its position and how many staircases there will be provisions to stop smoke entering the common escape routes. So if it's on a single escape, if there's only a single stair, then you may have to ventilate the lobby. If it's 2 stairs, then a lobby will be fine. And in certain circumstances, if the plant room doesn't have accommodation on the same floor, then that room can discharge into the common areas. So not for single, but it's always been controlled. It's always been controlled for multi-residences. Oh, sorry. Yeah. I've got halfway through. That's where that slide went. No, can you drop it back? Can you drop it back a notch, Rachel? Yeah. The other thing that is quite interesting, though, is and it kind of relates back to the next slide. If you look at that BBA certificate for a solar panel, the solar panel has been designated as B roof T4. It'll be difficult for you to see it, but it's there. And basically what is controlled, if that panel is attached to the roof, it's part of the roof construction, then remember those tests that the roof's subject to. In this case, this solar panel has B roof T4 designation, so that solar panel can be within 6 meters of the boundary. Now, there's certain solar panels, Trevor and myself had many a conversation when this first kicked off. We'd more or less considered solar panels that's located on flat roofs, which are not part of the roof construction, more or less considered them as fixtures, just the same as the air source heat pumps. We wouldn't look at the air source heat pump and look for a roof designation on that. But I think on the solar panels, my philosophy is, and I think it's backed up by the fact that they are testing them for BS 13501 and obtaining roof designations for them. So that side of it that's the control. There's a control there on the, because basically we don't want the solar panels to transfer fire from one building to another, just the same as we don't want the unprotected areas to do it, or the parent roof covering themselves. And the next slide, Rich, that kind of identifies, you know, that particular panel was a B roof T4, so it can be within 6 meters of the boundary. And there's the rest of the roof designations in 13501 and ADB, the C roof, the D roof, and the E roof. E roof would probably, well, F roof would probably be thatch. D roof, bituminous felt that's not protected. There's very little guidance upon what, well, not so much guidance, but simple data that where you would say, oh, well, that's a C roof or that's a D roof. The majority of people, of manufacturers, try and maintain that they get a B roof T4, because if it can't achieve a B roof T4, then it's got to be at least 6 meters away from the boundary, or notional boundary, as Trevor's shown. So it's the key is to try and get a a B roof T4. Be careful on the T4 is important. This was part of the little bit of a session I was going to do on the first question. The T4 is important because when the European guidance came out for the tests, everybody had a choice of 4 tests for the roof, whether it was test 1, test 2, test 3, or test 4. So the UK elected for T4, but some of the countries may have elected for T2 or T3. And so if they are exporting that material to a country that's T4 instead of T4 instead of what it was tested under, that test data may not be valid. So be careful with the T4 aspect of it. It's only relevant if the kit is coming in from a different country, and there's a possibility it was tested under a different test system, i.e. the Germans, I think the Germans went for T2, I think, don't quote me on that, but they certainly didn't go for T4. But I think they're wise enough that they know if they're going to export to the UK, then they've got to test for T4 too. So keep an eye on that one. And that's that.
Excellent. Right, back to me. And do replacement fire doors new? Rach, you've got a typo there. That's not like you. Need building control approval, or that's probably a typo in the questioner's typo that was just transferred to the slide. I'm sure it was. Do they need building control approval, or can they be signed off via a FIRAS certified contractor? Right, well, let's start the question by asking another question. Is it even controlled under the building regulations? There's a few colleagues in the audience, and I know I saw some rolling up, and they're all going to be maybe shouting at me. But I'm going to tell you how I understand it. It's been much debated over the years. And I used to say, well, come on, this is a like-for-like repair, isn't it? You know, why are we getting involved in it? But we do get involved, and the sort of nationally, the school of thought is that it is controlled work. I'll tell you why. I've got a slide next, I think, Rach, just to illustrate my answer. This is an extract from, oh no, one before, that's it. This is an extract, Regulation 3 from the building regulations, some of you be familiar with. And I'm saying that in changing out a door, it is a material alteration, because building work, i.e. building work which is covered under the building regs, are in these categories, one of them being a material alteration. And we say, right, well, why is an alteration material? Well, it's covered in clause 2 there. An alteration is material if the work or any part of it would, in red, at any stage, result in the building or control service or fitting not complying with a relevant requirement. Well, Part B in fire safety is one of the relevant requirements, where previously it did. So you're sort of taking the door off to replace it, and at that point it won't comply. And I think that's the explanation that's been given to me as to why it's controlled. So there you go. That wasn't the question, but it is controlled. Next slide, Rach. And so if it's installed by a FireAS registered installer, do you need to seek approval is effectively the question, isn't it? Yes, you do. A FireAS certified installer, FireAS is a third-party certification scheme for installers, and it's run by Warrington Fire, an esteemed and well-established company in the fire safety sector. But it doesn't mean it's a good indicator that the job is going to be done properly, but it doesn't mean you don't need to make an application. The only work that you don't need to make an application for is work done by an installer under a competent person scheme. That if they are registered with a competent person scheme, and the schemes are all listed in Schedule 3. I've just given you a quick extract of the first part of that schedule. And that's where you see organisations like HETAS and NAPIT and FENSA, all those familiar names that we know that our electrical work can be self-certified, our window replacements can be certified, and some plumbing works and some roofing works. But you won't find in Schedule 3 anything that says that FireAS is a government-approved scheme, so that's why they can't self-certify. So there you go. If you want to know what is covered in competent person schemes, look at the latest version of Schedule 3 and you'll see all the listed organisations who are government approved. So I think that pretty categorically answers that one, and I can hand back to Les for question 5.
Right, were the sprinkler systems mandatory on buildings in the UK? Well, the one that we obviously very aware of is multi-residential buildings, or any residential building for that matter, where the highest floor level is above 11 metres. The BS 991 still got to catch up because that says 30 metres, but give the industry their credit. Nobody is, and we've had probably 30, 40 applications in for buildings over 11 metres in the last year. Not one fire engineer or one developer said, oh no, we're not going to, we are going to design the building to BS 9991, and 9991 categorically says 30 metres. They've actually gone back to the ADB, which says 11 metres, and they have actually come back. One of the big problems we always had with people is, especially when in this country, we're probably the only country in the world who's got two standards. We've got ADB and we've got Volume 1 and Treble 91, and the similar correlation between ADB Volume 2 and 9999. And people have always wanted to cherry pick from one or the other. This is the only case where they've cherry picked in the other direction. You've got to give the industry huge credit for that, because it's a complete rarity. So that's the classic as far as residential is concerned. The rest is 30 metres. You know, so it's can you pick the second one? Did I put a second slide on this one? I think I did, didn't I? Yeah. The second situation is offices. Was it offices, shops, assembly, recreation? Anything over 30 square meters, 30 meters in height must be sprinkled. So 18 meters, 11 meters for residential and 30 meters for anything else. On the slide, I haven't mentioned the 30 meters, and I put 18 meters, which is wrong again. It should be 11 meters. That's one of those, that's another clanger I've dropped. So I've dropped 2 clangers on this slide. That 18 should say 11, and everything, you can more or less say everything else is 30 meters. But what sprinklers do, and I do various sessions on sprinklers, sprinklers change everything, absolutely everything, and they can mitigate against the 4 situations there which I've identified below, and that's what Trevor was talking about. excessive unprotected area, and he was talking about the 12 kilowatts at the emitter. So from a defensive position, your building, if you're in the building that's not burning, you do not want that any part of that building to exceed 12 kilowatts a square meter, because it stands a good chance of igniting through burning brands and things like that. Now, if that building that's on fire is sprinkled, then the heat that's emitted from those unprotected areas is assumed to have halved. The reality is probably tensed, if that was a word. It's probably it's common. It's an unwritten law that it's very rare that a fire that's sprinkled exceeds 100 degrees in the compartment. The gas temperatures exceed 100 degrees in the compartment. It could burn all day and it wouldn't produce 12 kilowatts per square meter of energy at a building that's as calculated in accordance with what Trevor was talking about. So it can mitigate against excessive unprotected areas, so we can bring buildings closer together where there's no fire resistance of the external walls. It can mitigate, and to a certain extent, you can only go like schools, for example, schools. Certain industrial buildings can go over 8,000 square meters without being sprinkled. But the second you sprinkle them, that might mean that the compartment sizes can be uncontrolled. So it can mitigate against compartment sizes. Where fire resistance can't be achieved for architectural reasons, perhaps the architect wants, all the steel work to be exposed, or other reasons. Again, the sprinklers can mitigate against for a lower standard of fire resistance. And in travel distances, can be increased as well if the building's sprinkled. There's not a direct correlation between sprinklers and travel distance, except for residential. If the units are sprinkled and the common areas are ventilated, then you can double the travel distances. You can possibly even quadruple them if you mechanically extract the smoke from them as well. So sprinklers, although there is not probably one size fits all as a fire safety mitigation system, but sprinklers comes very, very close. And yes, they're only required in two situations: 11 meters for residential. You can almost say 30 meters for everything else, and you won't be far away. But the biggest advantage of sprinklers is those four aspects there. And that, I don't think that is it.
Yeah, we've just got a couple of notes in the chat there about residential care homes. I think Will Jones might be from Wales. He says, Welsh Builder had specified that sprinkler systems are mandatory in all residential care homes. Colin Cox goes on to say UK includes Wales where sprinklers are needed. So
they're mandatory in Wales. They're not mandatory here at the moment, as far as I'm aware. Certainly the last two care homes, but what they also do, they're a lot more resilient because they go up to a category 3. So there's more resilience in the sprinkler system as well, more resilience in the water supply, and more resilience in the protection of the power supply too. So, and I would imagine that whatever's the case in Wales, it'll probably follow to the UK.
Thank you. I'll swiftly move on to number 6.
Yeah, thanks for the contributions from the floor there. That's useful information, and clearly some people are picking up on that and finding it handy. Right, question 6 is down to me. Are there any new rules or regulations from the last 3 years that surveyors should be aware of? So somebody's come back from a nice 3-year career break or something, I guess, and wants to pick up where they left off. So what's the answer to this? Short answer, yes, there is. Substantial. Where do I start? There's no point trying to give a comprehensive answer, is there? Because we've already done several webinars covering a lot of the changes that have been made. And you'll find those on our library that Rachel's put together. It's on the events section, isn't it, Rach, of the website? And there's a lot of there for you to dig into. But just very summarised, of course, we've got most lately FLOS, FLONS, ventilation. The approved document and regulations have changed, as have Part L, energy conservation, Part O, overheating of buildings, recognising the effect of the enhanced energy conservation regs are going to have on buildings, and I covered that in a little seminar recently. Part S is, of course, electric charging of vehicles and the provision for facilities to do that in new buildings and buildings undergoing change of use. Hopefully Les has got his head around that more than me, because I had a look at the book and I was a little bit depressed, to be honest, by the complexity of some of the considerations there. Les has already mentioned the sprinkler changes. Now we look for them in flats over 11 metres. Of course, we've had the effect of Grenfell and the non-combustibility of facades in residential buildings over 18 metres. We're seeing a root and branch shake-up of the regulatory system, aren't we? We're going to have a new national regulator. All my colleagues are going to be regulated and have to be licensed building control officers. And most recently, we've got these new amendments that some of which, well, we had a change coming in June of this year, where cavity trays have got an amnesty from the requirements to be non-combustible in high-rise residential buildings, and also on the back of the same legislation there, December 22, we've got some new requirements coming in, mainly to do with the combustibility of the facades of buildings and changes to buildings over 11 metres, not to bring them up to the same standard as buildings, residential buildings over 18 metres, where the whole fabric of the external walls have to be non-combustible, but certainly the external surfaces have to be non-combustible. So I'm whittling away, aren't I, trying to get out all this information that's there. If there's topics there you want to expand on, if there's stuff you think you want to know about more, just contact Rachel and she will then badger us to put something together for a future presentation. That latest set of regulations that we're seeing, it's niche, it's mainly to do with high-rise buildings over 11 metres. But if there's a market out there that wants us to cover it in detail, we will do so. That's no problem at all. So there you go. Not a full answer, but hopefully we'll just we'll do for the time being. Right, Les, back to you. Batting back to you.
All right. Yes, it's an interesting one. And if we go back to fire dynamics and the whole, go back to basics, there is the evacuation policy and the fire alarm are joined at the hip. So as a general rule, if it's simultaneous evacuation, then the fire alarm will be designed in accordance with that. And exactly the same occurs if it's stay put, then the fire alarm will be designed for stay put. And let's go back again to like 1973 to CP3. And this aspect of stay put has always been a relatively new phenomenon, or a relatively new word, I should say. The fire brigade call it defend in place. There's a million different ways of describing it. But what this 1973 CP3 said, well, you can either stay where you are in the event of a fire if you feel safe, or if you feel as if it's necessary to escape, then feel free to escape. The fire brigade their advice has tended to be, well, unless we tell you to escape, then really you should stay where you are, because on the whole, that's the safest place to be. So it's always been good advice. In my opinion, it's always been good advice. Everything that could go wrong did go wrong. But some of the things, the major things that was criticised, and criticised in the light of hindsight, rather than in the light of battle, and this was more or less one of them, is that the fire brigade were supposed to, oh, you should have evacuated the building. Well, how on earth were we going to do that? You know, it's always going to be a very difficult thing to do. It would have been putting firefighters in danger, and it would have been putting them in a situation where you may be sacrificing one life to save another, or a very, very difficult position to be in. And so as a result of that, this is basically the guidance. Now, Rach, have you got the next slide? Have you not on there? Do I need to? Have you gone? No, you haven't. Let me share my screen. And then all of a sudden my screen's just changed. Oh, there we go. Can't see wood for trees. And slide show that.
Yeah, I've stopped sharing my screen, Les, so you should be okay.
So, right, okay, so if I share that. And now, share from current slide. Can you see that?
Yeah, we're good, Liz.
Okay, well, this is what's come out in the circular. Evacuation alerts. Provision have been made for the introduction of evacuation systems to be provided in accordance with 8629s in blocks of flats, 1A, 18-metre rule again. This will help the fire and rescue services to alert the residents to a change in evacuation strategy during an incident alongside existing communication methods. The method that, what we've always assumed is, we've always assumed that the compartment will protect us. And the more or less the principles being that if you're in the flat that catches fire, you leave that flat, you escape from that flat. And whether you alert the neighbours or not, entirely up to you. The smoke, if any smoke gets into the common corridors, that will activate the smoke control system, but it won't raise an alarm. And so the only way that anybody will actually know there's a fire in the building is if they can hear the unit of where the fire is actually taking place. So that guy will escape, and the fire brigade probably on current policy, I can't speak for them directly, but on current policy, unless they think that compartmentation will be breached, they'll fight the fire in that particular situation and without evacuating anybody. Now, what the golden rule is, I'm reliably informed that when that fire breaks compartmentation, i.e. it looks as if, or it has spread to another unit, at that stage you've got to at least evacuate the floor, and possibly the floor above it and the floor below it. And that was where the lessons to be learned from Grenfell came from, was that the fire spread to the next apartment up very, very quickly, and yet they maintained the stay put policy. And they would have evacuated if they could, but whether that, you know, being in the heat of battle is a different situation to being in a courtroom 6 or 7 months afterwards, suggesting that this and that should have happened. And basically what this guidance is here to provide is so the fire authority can, at the point where they think compartmentation is going to be breached, or even if they anticipate compartmentation to be breached, they have a communication system to each floor of the building, whereby they can ask the occupants to evacuate rather than to hold them into position. And it's a direct result of Grenfell. And that's how it mixes. It's how it mixes in. It's almost like a phased evacuation. So it is stay put. It's stay put until you are informed to evacuate, and that decision is best rested with the fire authority. So that's how it ties up with stay put, and hopefully. In the unlikely event of a fire occurring with a building in this condition, it should work well. But having said that, if it's a relatively new building, we've got the only area where that wasn't particularly well controlled was the external wall, and the external wall now is being well and truly tied up by Regulation 7. So tie the external spread up with Regulation 7. And now we have, the intentions to have an evacuation alarm system in accordance with that British standard. Then, all of the lessons, I think all of the major lessons from Grenfell will be learned. First of all, the external wall, and second of all, the fire authority having the ability to evacuate the building if they need to do so.
Thank you, Les.
Can I add just the end of that? Yeah, the new requirement for the evacuation alert system comes in December this year. So that's just, loose end. Sorry, carry on.
Okay, no, that's me done, and I shall stop sharing, Rachel.
Okay.
Right, yeah, back to me. Yeah, we are running quite long here, and we need to be more succinct. So I'll try and be. Deflection heads, yeah, I can when they're required. Yeah, I mean the deflection head. It's usually a non-load bearing partition. It's under a roof or a floor where it is anticipated there will be a degree of deflection. And if you get deflection, then you get potential damage, you get load imposed on that partition, and then you get potentially damage in the partition and in the finishes, which is not a good thing and needs to be considered for all partitions, really. But particularly, of course, for building control people, we're worried that any damage to that partition may affect its fire resisting properties. It may be a compartment wall between compartments or between dwellings or something like that. So that's where we look for this deflection head detail to be put in, which allows for some degree of deflection. And you've got to be talking to the designer's got to be talking to the engineer and to work out what that level of deflection is. I think in the regulations it quotes that we should assume 40 mil, unless there's any engineering justification for less than that. And of course, that's not just live and dead load deflection that will naturally occur in any building to various degrees, but also if there's a fire, you're going to get even more risk of deflection as materials heat and are affected and distorted by the fire. So that's just a quick image of some of the bog standard British gypsum deflection heads for various fire resistant situations. Sorry, the text is quite small. I can hardly read it, even with my lenses in. So, but basically there's a sort of 30-minute and 60-minute deflection heads. And what you're seeing is that the metal studs are not carried to the top of a channel. So you've got a particularly deep head channel. The head channel is mounted on usually a strip of plasterboard, which is the grey strip above, which is maintaining fire resistance. And then you've got a little red strip there. That's an intumescent sealing strip to seal between usually it'll be a concrete soffit and the top of the partition. So the stud is not connected to that deep channel, so it can slide up and down if there is any deflection. And of course, the plasterboard is kept short of the ceiling or of the floor or roof, so that the plasterboard doesn't come under load and crack and distort. So next picture, H. What we look for, yeah, there you go. That's a good textbook example. You see the top ceiling strip, you see the gap at the top of the stud there. No fixings between the stud and the channel, so that it can move, and all is good. And yeah, we need to look for those. I'm not sure that building control perhaps are as hot on these as we should be. We sort of rely on designers to talk to each other and engineers to talk, and that they get incorporated. But it's only when there is fire that they get found out if they're not detailed properly. And of course, you've got a big span. Of course, everyone wants big spans now on these buildings. You could have quite a degree of deflection, and you've got a partition running right under the mid span of that. You've got a recipe for a problem. So hopefully that explains what they are and where they're used.
Yeah, we certainly pick them up on majors, Trevor. So it's one of our first questions.
Yeah, our HBC special major projects, I don't have any doubt at all. I have 100% faith. Right, is this one me as well? So sorry, yeah, I think I've got two in a row. Loft conversions with automatic fire detection throughout, thus retain existing doors. Right, well, this is, yeah, loft conversions. Usually you have to create a protected escape route, don't you, from the stairway? There's this option that has come to the fore, that you can, rather than swap out all the fire doors, or swap out the existing doors for fire doors, FD20 doors, you can retain the existing doors and then just put this enhanced L1 fire detection and alarm system to compensate for that. A bit of a Ronnie Corbett. I've got to give you the background to that. Where did that come in? Where did that come from? You won't find that in an approved document. Well, in 2010, we had a publication called the CPA, the Construction Products Association Loft Conversion Guide, and it introduced this idea of what they called the fire engineered solution. Option 4 in that guide for fire safety in a loft conversion was to have a sort of a type A or type B AFD system to compensate for the lack of fire doors. Well, this brought in a lot of debate. At that time, we'd just seen the need for self-closing devices to be cancelled on fire doors in loft conversions. Older people amongst you remember when we used to have those. And so, you know, an open fire door is no good at all, is it? And it's not got a self-closer, it's more likely to be open. So this looked like a good option, but people were misapplying it. People were saying, yeah, put a few smoke detectors up and don't worry with fire doors. And this was coming back to local authority building control, and it was resulting in people using maybe a private sector provider rather than LABC because they'd give an easier line on this subject. So we came up, I say we, this was Hertfordshire Building Control, the technical forum that I chaired at the time. We came up with this option to have enhanced fire detection. We came up with a quite a rigid specification for that, and that was from guidance by a qualified fire engineer and an expert on a national expert on AFD at the time, and that was adopted in Hertfordshire. It was very popular, and it was also adopted around the country, and a lot of people were very happy to have that and agreed with the principles and the way it had been formulated. Right, well, so there's the background of where it came from. Of late, when I was sitting on the national technical group, I asked them to maybe look at this as a national standard, and around the table there was a great deal of support for that. But I think everybody's nervous to do anything like that in the light of recent events. So it's not happened. Whilst existing doors should be well fitted, what type of existing doors are or are not acceptable as part of the guidance? Well, the guidance is really saying we need to get people out of the building. We're not going to rely on a 20 or it will effectively be an FD30 door to protect them from the fire within the room where it emanates. So if we're getting people out very, very quickly, an L1 system obviously is going to be throughout the building. Any room where a fire can start will get an instant detection, or not instant, but it will be as soon as smoke is detected, it will create a warning, which of course it's a linked alarm system. So, a dozen smoke detectors will be singing out that will wake the dead, and people will be out of there very quickly. So the fact that a door might only hold back smoke and fire for 5 minutes is not really a big deal. So if it's a glazed door, or maybe it's a veneered egg box door, again, it's academic. The evacuation is as fast as it could possibly be. So that's the principle that was behind this, that was devised, as I say, by industry experts. And the answer is, as far as we're concerned, the door specification is not critical. But obviously, it is always a good idea to have a door which is reasonably decent fit. So sorry it was a long answer, and we didn't really have time for it, but you got it anyway. Les, you're
right.
back.
Yes. Right. We're looking at a number of residential tower blocks in the borough. This has come from a London borough, and have noted to prevent overheating in the corridors, communal areas, heating pipes are insulated with a PIR material. Our concern is the use of the material within suspended ceilings, and the suspended seams often perforated to keep the reverberation sound down. Over escape and firefighting routes could be an issue, with the potential of PIR to drip and release toxic substances. The guidance in both 991 and Part B does not appear to cover this. Is it a genuine concern? It's a risk, but I don't think it's my feeling is it's not a concern. Now, if we go back to the fire dynamics of PIR can reduce, because there's isocyanate, it has got cyanide within the molecule, and it can release it under certain situations. But my feeling is that that's not really the issue. My feeling is that the common areas are at the very least tenable, what we try and maintain a tenable condition. That's the purpose of, if it's a staircase, it's a firefighting staircase or a normal staircase, that's sterile. We don't want any smoke or anything in that, and any smoke that does get in there, we try and get rid of it with the AOV. The corridors are considered as what's called tenable, i.e. what we try and do with the corridors is we try and keep them under a certain temperature. We try and keep any smoke that does get into there at high level, and we try and ventilate it out. And any radiant heat points we try and keep to an absolute minimum. So it's a tenable area, and where the heat that's necessary to combust PIR under normal circumstances won't exist. Now, what PIR does do, it chars, it doesn't melt. It hasn't got a melting point. If you look in the description of PIR, it'll give you a heat of combustion, and when it comes to the point of what's its melting point, it'll be a dash against it, and next to it says it chars, and that was proven on Grenfell. Most of the PIR and the phenolic foams was still on the building afterwards, because initially it would have combusted and then it would have charred, and that's the case. So as a general rule, I'm not concerned about it, but this insulation will happen. It's not only for keeping the corridors cool, but also in many of the larger flats with communal heating, there'll be a flow and return in there as well. So the flow and return will be insulated, and so it's not only to stop the corridor heating up, but it's also to stop any heat loss through the pipes. But like I'm saying, my feeling is and again, it all revolves around the other areas. We've got two fire safety renovations of existing tower blocks. One has sprinkled them all. Stevenage has sprinkled all of the towers, and Harlow have increased their smoke ventilation, made the smoke ventilation better. Now, neither of them fully comply with the 18-meter rule. Neither of them do so. So when you've got an existing tower block, then everything's a risk. If you haven't got full comply, if you haven't got them all sprinkled and the smoke control isn't perfect, then I can understand why you would think that it's a risk with the insulation. And under those circumstances, I wouldn't see any reason why you shouldn't remove that PIR and replace it with a mineral wool because of other non-compliances. The thing is with fire safety, certain aspects are allowed to fail, but if you haven't got full compliance to begin with because you're dealing with an existing building, then whatever you can do to minimize the risks, then you would do it. And if the people at the London Borough consider it as an issue, then they should replace that PIR with a mineral wool heat lagging that's covered with an aluminium foil.
Okay,
Make sense?
Thanks. I'm going to stop sharing my screen there. So we're running over an hour now. I just want to give if anyone wants to feedback at all, speak up now. I thought I'd give you the chance. I don't want to keep going past you the questions. What we'll do for any more questions is we'll get back to you either individually or afterwards on the document.
Come on, Lucy, what do you reckon about the PIR insulation over the pipes? You must have a view on that.
I think it was an excellent question.
It was.
It got me thinking. Yeah, a really good question. Probably the best, to be fair. I don't know who put it in or who come up with that, but yeah. I had never considered it before, if I'm totally honest, until today. So yeah, certainly made me think a little bit more now. But I liked your answer as well. I tend to agree with what you I don't know that I would have done necessarily to begin with, but then when you sort of explained it, I was like, yeah, actually that's a fair point, hence being here to gain from your knowledge.
Crikey, they are. That's an accolade from the fire brigade, Les, in that one.
I'm not fire brigade anymore though, am I? Not quite.
Oh well, you accolade from an ex-fire brigade, that's almost as good.
I still support as much as I can, obviously, but yeah, moved on.
Thank you, Lucy. Anybody else? Okay, if no one else has got anything to put forward, then we'll bring that session to a close then. Everybody on the call today will get a CPD certificate from myself, so keep an eye on your emails. I'll get those out to you.
You've got a question there, Rachel.
Oh, I've got a hand up.
Yeah.
Okay, Tony, do you want to fire away?
What's this week's view on what an FD20 is at the minute?
Do you want to take that, Les, or shall I?
Yeah, I'll take. It's only ever existed in the guidance documents, Tony, hasn't it? To be fair, you couldn't buy an FD20 door regardless of how much money you had. So everybody, as you're well aware, everybody just upgrades it to an FD30.
I think Tony might be alluding to and correct me if I'm wrong, to the possible need or not for intermittent strips. Yeah, thumbs up. So I'll take that bit and I'll say,
keep going, Trev.
When I argued long and hard. The agreement came in nationally that a door certified FD30, i.e. tested in a kiln, could be used as an FD20 door without intermittent strips. Even if the kiln test had intermittent strips to show FD30, yeah, FD20, it would be good enough with a decent fit. And I remember arguing and made a right nuisance of myself. This is before I was on the National Technical Group. Why they ever let me on it, I don't know after that. And said, look, burn a few doors and then say that, because how can you assume that? But there was a vast majority who said, no, this is where we'll go. And for a long time, that's been the case. And you'll know that, Tony, and you'll have probably applied that rule throughout a lot of your career. Well, of late, and it made me chuckle sitting around the table at the National Forum. People were saying, well, why have we ever accepted this? You know, how is this proved? And the latest school of thought is that that's wrong. A fire door is only a fire door if it's installed exactly in accordance with the certificate that tested it. Now, nobody's testing FD20 doors. There's no market for FD20 doors, so nobody's bothering to spend the money to test them. So in the absence of that, until somebody does and markets a door at that level, we assume that you'll have to go to FD30 and then strips are applicable. So the short answer to your question, yes, we're looking for strips again now, as of a few months ago. So there you go. Joint answer.
Okay, thank you. So thanks everyone for coming. Great to see you all. And next meeting like this with your questions will be on FLONS. So they're open for registration now. There's 2 dates. So if you go onto our website under events, you'll see them both there, and that's available for registration. But I'll also be sending an email around inviting you to those. Okay.
Thanks, Rachel. Much appreciated.
Cheers all. Thanks for turning out. Much appreciated. Hope it was of some use.